of f at x is given by that, and g of x are drawn below. A point of intersection of g and f is b, the turning point of f. The graph of f has an x-intercept at -3 and 5, and y is the y-intercept at c. Write down the coordinates of the turning point of f. 5.1. So whenever you have a parabola that is given in this form, these two will give you the coordinates of the turning point. This will give you the x value, and that will give you the y value. So in this instance, B is the turning point of f, and then x is going to be 1, and then g, and then the y is going to be an 8. 5.2. Calculate the coordinates of C. So they told us that C is the y-intercept of f. So f at x should be equals to -1/2 x minus 1 squared plus 8. For y-intercept, set x equals to 0. So f at 0 should be equals to -1/2, 0 minus 1. 0 minus 1 squared plus 8. So I'm getting 15/2. The coordinates of C, 0 is 2, 15/2. 5.3. Calculate the value of D. So g of x should be equals to d over x. We need to find a point that is on g in order to find the value of d. So they told us that a point of intersection of f and g is b. So we are going to substitute b, which is equals to 1 is to 8. 8 should be equals to d over 1. Therefore, d should be equals to 8. 5.4. Write down the range of g. So for the range of a parabola, we use the coordinates of the turning point. The maximum y value there at b is 8. So the range should be equals to y is less than or equals to 8. Okay, so 5.5. For which values of x will f at x multiplied by g of x be less or equals to 0? So we're going to do this. In order for something to be less or equals to 0, you must have a negative value. A negative value or something that is equals to 0. So we need to look at where f at x is negative and where g of x is positive. That's the first scenario. The second scenario, we need to look at where f at x is positive and g at x is negative. Okay, so for f at x is negative from here to there, and then it is also negative from here to there. So it is below the x-axis. From here going this way, and then from there going that way. Okay, so where is g positive when f at x is negative? So f at x right there is negative, but so is g of x. So that can't be it. From this point going all the way to 5, f at x is positive, so we can't look at that part. But from 5 going downwards, f at x is negative, and then g of x is above the x-axis. So for the first part, x should be greater or equals to 5. Then for the second scenario, we are going to look at where f of x is positive and then where is g negative. So we can see that f at x is positive from this point going all the way to 5. But g is negative from here to there, because from this side g is positive. So g is negative from this point to that point when f at x is positive. So, or when x lies between -3 and 0. 5.6. Calculate the values of k so that h of x is equal to -2x plus k will not intersect the graph of g. So g is like that. That's the graph of g. We are told that h at x is -2x plus k. Is -2x plus k. This gradient is negative. It means that the graph of h of x can either touch g there or it can touch g there. K is the y-intercept of the graph of h of x. So k can be any value in between. K can be any value. It can be any value here between where the two graphs touch. Okay, so we need to equate h of x and g of x, because in order for us to find where they do not touch, we need to know where they touch each other. So h of x should be equal to -2x plus k, and then that is 8 over x. So I'm just going to multiply by x. -2x squared plus kx should be equals to 8. -2x squared plus kx minus 8 should be equals to 0. Just going to divide by -1 minus k of x plus 8 should be equals to 0. Here we are going to go back to the basics of the nature of roots. Whenever we have something like this, we're going to use the discriminant. So the discriminant is equals to b squared minus 4ac, where b is minus k squared minus 4, a is 2, and then c is 8. So this is k squared minus, so that's 64. Okay, so we know that the value of k should lie between this point and that point there. So k can be anywhere between these 2 points. So k squared minus 64 because it shouldn't touch. If at the point of intersection the two graphs are equal, meaning that if like we equate this to 0, we are saying that the two graphs are equal, but we are looking for the point where the two graphs do not touch. So k must be between the two graphs. So this is k squared 64. Therefore, k should lie between 8 and negative 8. H is a tangent to G at R, a point in the first quadrant. Calculate T such that y is equals to f at x plus t intersects G at R. So H is a tangent to G. H at x is given by negative 2x plus k. And then G of x should be equals to D. That's an 8 over x. H is a tangent to G at R. So we need to find the x value where H is a tangent to G. We need to find the x value of R. And in order to do this, we need to find the derivative of G. So at R, the gradient should be equals to negative 2 because we are told that H is a tangent to G. So the gradient should be equals to negative 2 . So this is 1 over 4 x negative 2. So 1 over 4 should be equals to 1 over x squared. So we can just say x squared should be equals to 4. So x should be equals to plus minus 2. But in the first quadrant, x should be equals to 2 because x is positive there. So what is the y value when x is equals to 2? So f at 2 should be equals to, we need to use G, not F. G at 2 should be equals to 8 over 2, which is equals to 4. This means that the coordinates of R are given by 2 is to 4. So y should be equals to f at x plus t. Y should be equals to 4. F at x is given by negative 1 over 2, where x is 2 minus 1 squared plus 8 plus t. So this is negative 7 over 2.